Hi everyone, and welcome to a new edition of Talks by Softbinator. We've reached 156th edition so far. I've Googled, of course, before starting this edition, I actually went on Wikipedia and searched if there is something interesting for the number of 156, and apparently it's the atomic number of unpenthexium, which is quite interesting. Anyway, coming back to our audition, we have two incredible speakers tonight. The first one is Elif. Elif is a senior DevOps engineer at Web, one of the few Red Hat certified architects in Romania in infrastructure. And she'll talk to us today about end-to-end encrypted backups, recovery solutions using Ansible, Molecule, Hashicorp Vault, and Restic. And yeah, because backup is crucial, and unfortunately, most people understand that only after they need to actually restore a backup. Our second speaker, which will be after Elif, is Daryl Cullen, which is a very experienced programmer and manager, currently DevOps Cloud Manager at Ericsson, previously Director of R&D at Volvo, with a vast experience in a multitude of domains from air traffic control, nuclear power, space industry, and automotive. And his talk tonight will be about how Ericsson is accelerating innovation in automotive through cloud connectivity, which will be an extremely interesting subject. And coming back to Elif, I haven't pronounced your full name, Elif Mosessohn-Samedin.
Elif is more than enough, thank you.
Uh, okay, so hello and welcome to Talks.
Thank you.
Uh,
Thank
uh,
you for the invitation.
I will give the microphone now to Elif. Daryl will be with us after Elif's presentation. So, Elif, you're an advocate for continuous learning, open source communities, and technical innovation. And I guess tonight you're also an advocate for backups and their role in all organizations. And probably everyone should have a backup, even on the personal level. Uh, with everything. I'll let you take over and tell us why backups are important. But before that, a few words about you and what drives you and how did you actually become one of the few Red Hat certified architects here?
First of all, good evening, everyone, and welcome to another Softbinator talk. First of all, you guys have been doing an amazing job. Well, with such an introduction, there is so few of me to say. How I started my journey, everything started with being curious. I wanted to try something new. Uh, I took part at some point in some hackathon. I was a newbie in Linux stuff, but I didn't have food for a day trying to write a basic bash script. That was the moment when I realized there was something. So I started to explore more and more about what DevOps means, what kind of culture it promotes, what are the best practices, and ever since then, I continuously try to improve myself, learn the in and outs of Linux. Furthermore, I try to enable teams to automate workflows, delivering quality software, enabling them through the delivery. Lately, I've been diving into containers world, Kubernetes ecosystem, and so on. About becoming a Red Hat certified architect, it was just a dream. A few years ago, I didn't understand what it actually meant. I started the road, and thankfully, I had amazing people around me who mentored me, guided me, coached me along the way. And as a large brick, let's split it into smaller steps. And through each step, I got closer to this dream.
Awesome. So, backups.
Indeed. Let's go back to backups. When did you lastly performed your backups? Actually, I'm curious about this.
You're asking me?
Yeah, I am.
Well, for my organization, we have rolling backups, so they're automatically created, I think, every day. Every day, they're their continuous backups. I think they go back a month maximum with everyday backups, and then we keep a few of the monthly backups as well. So we have even further than that. But on a personal level, I have everything in cloud. Like all my code is in GitHub. Uh, all my code is in GitHub, and all my photos are in Google Photos, and all my desktop and documents are in OneDrive. And I'm hoping that their data centers don't uh, go down and burn, because I had this problem recently this year with some OVH servers burning to the ground, and I did not have backup to those, but thankfully there was nothing important there. So I have
Well,
backups to the important stuff, and I rely on others for backing up my personal data.
what about backing up the backup? Well, there could be times where at least two backups are necessary. Well, let me present you another approach to performing backups. At AutoWeb, we have I think, a slightly different approach. Could be helpful, and let's see how this goes. I'm gonna
Awesome.
start also my screen share.
I'm gonna hide myself again now.
Once again, welcome everyone, and I'm happy to be a guest here at Softbinator Talks, lucky number 156. I'm Elif, and today's story is about the manner of performing regular backups of our data. Well, we already have an example of a good practice of how backups are performed, either at a personal level or a professional one. How about recovery? This is also an interesting topic to be approached. I'm gonna actually skip this part. I had such an amazing introduction from our friends from Softbinator that there is nothing else to be left. I'm gonna just simply deep dive into the today's topic. Let's start with the acknowledgement of the current situation. Let's identify the opportunity, and by the end of the talk, let's glue every element together and and discover together the end result. First things first, what is actually a backup? Well, I think the image from Dilbert, of course, I don't own this. Hopefully, it's everything all right with the copyright as it appears in the image. What happens with backups? What are those? Well, backup is no more than a copy of certain data to be recovered in the event of a failure. But then the next natural question would be, what failures could we actually face? Starting from either hardware or software failure to data corruption or even human-caused events such as malicious attacks or accidental deletion of data. Then what do we do? How quickly do we need to recover the lost data? What happens in case we are not able to entirely recover this data? How do we ensure in case of backups that these are these of their integrity? How do we restore services to the initial state of functioning? Because more often than not, losing data means also service interruption. These are some important questions I'm trying to answer together with you guys today. However, despite the fact that the situation might not seem so pleasant, actually there is some opportunity there. Because using 4 tools, we are going to perform a full backup and then restore our data. And these tools are Packer from Hashicorp, Ansible, Restic, and Vault. Let's deep dive into each of these a bit, and then everything will come together. What is Packer? Packer is a lightweight, open source tool that enables us to create identical machine images for multiple platforms, such as AWS, Azure, Google Cloud Platform, and, as we'll see further, Hetzner Cloud. A common use case for using Packer is creating those so-called golden images for teams across an organization that can use in a cloud infrastructure. Next would be Ansible. Not sure how many of you have heard of Ansible or have been using that. In a nutshell, Ansible is an open source platform. It is a simple automation language that is able to describe an infrastructure through playbooks. A playbook is no more than a collection of tasks that are executed against a certain set of servers. What is particular about Ansible is that it is built around an agentless architecture. Typically, Ansible connects to the host it manages, either using OpenSSH or WinRM. And some of the strengths I'm gonna also, I hope to show you a bit further, would be the fact that Ansible supports dynamic inventories. What is an inventory? Let's say, imagine it as a recipe of ingredients. In our case, the ingredients are no others than the servers against which we aim to execute some tasks. Dynamic inventories means that we are aware which servers we manage in our infrastructure, regardless of the time or location of this. So we are able to retrieve a list of servers we manage at any time. In comparison, there would be the static inventories, and as the name suggests, we would need to define these by hand, which is not that easy anytime. Ansible also is very easy to use because it uses YML and it is easy to read. The code is also a documentation of the infrastructure itself. Well, this would be, let's say, a few advantages of using Ansible. Next into scene would be Vault. Let's not confuse Vault from Hashicorp with Vault from Ansible because they have different functionalities. In our case, we are discussing about Vault from Hashicorp. It is a tool for securely accessing secret. But what is actually a secret? It is everything we want to tightly control access to, such as API keys, passwords, and certificates. And last but not least, this funny logo belongs to Restic. Restic is a modern backup program. Its aim is to backup files to different storage type, either self-hosted or online services. All the data which is stored by Restic is encrypted, and these encryption keys are managed using Hashicorp Vault. That would be a quick overview of the elements we are going to approach. And now everything comes together. Well, I'm gonna stop the presentation and actually start sharing my terminal. Radu, could you help me with a confirmation that you are able to see my terminal?
I can see your terminal. If you can zoom in a bit. I don't know if people on Facebook are able to see the text well. Just a bit.
Would this be better?
I think.
Do you have by any chance, any feedback from our viewers?
I am. Yeah, if someone can confirm in the comments if it's viewable, well, that would be great. I guess you can start. Yes, we can. Okay. Yeah, they
Okay.
can see it. We have a bit of delay between when we talk and when it arrives to Facebook.
Yeah, I've had previous experiences with live streamings. There are a few seconds delay.
Someone asked if we can zoom in a bit more.
A bit more.
A bit
Okay.
more.
Sure. That's great feedback. Better now?
Yeah, let us know if it's better now. Yeah.
Okay. Thank you everyone for your feedback and involvement. It is really important and really helpful in performing a good presentation. So, up to this moment, we talked about Packer, Ansible, Vault, and Restic. And now I'm trying to glue everything together. Let's start from Hetzner. I'm sorry. For this demo, I have created a project, and the project is called Sofbinator. Within this project, I only have a server, to which will come in a few seconds. What I want to highlight is the following. I have uploaded to this project a Packer image called Sofbinator CentOS 7. It is a server image based on CentOS 7, on top of which there are 4 Ansible roles executed. From this image, I'm gonna build up a server using Terraform. For the Terraform code, I have written a module, especially for spinning up servers in Hetzner Cloud, only by providing a few, let's say, custom variables. I'm gonna switch to my Atom code. And the server I'm gonna build is called samedin.raw. It is a CentOS 7 image, and I've given a few parameters. What is particular about this, and I want to highlight to all of you, is the fact that as soon as Terraform spins up the server, it will call another Ansible playbook, which in turn is responsible for calling a role. This role is responsible for configuring the backup side. Well, this would be the first part. Let's do the actions up to this moment. Oh, and I forgot one small detail. I have also started a Hashicorp Vault server in development mode. The particularity of this server is the fact that the storage is in memory. This means that despite the fact that you are able to see here a root token, this will go off as soon as I stop the server. But for this demo purposes, well, it is not a best practice to show off passwords.
So don't hack the server.
Oh,
In the
please do
meantime.
so. I dare you. There is nothing too sensitive yet. It will be soon. And within this, I have created an engine, a key value engine. It's called Restic. This key value engine is responsible for storing passwords of, of the type key value. And I'll come back to it in a moment. Let's spin up the server. Let's see. The Terraform plan shows us that I'm gonna build a server as I'm expecting to. The Ansible playbook will be called by a null resource, and you'll see here also that the ID of a floating IP will be updated. I have also creating the floating IP to associate with this server. So these are all the expected updates. Let's go on with the Terraform apply and hit the big S. Cool. It will take a few moments for the server to be up and running. Okay. Meanwhile, what I'm going to do, I promised to you that I'm going to explain what this server is. Backup.samedin.ro is the backup server to which I want to store the backups. How is this performed? Well, the answer is quite simple. This is performed by the Ansible role I was explaining before, and all the definitions are to be found in the host vars associated file with this with the server we are creating now. I have defined the remote server. Well, it's only the IP of the backup server I was telling you about, and the path which will be backed up. Let's see how this server. Oh, it takes a bit of time. It was quicker when I did this earlier this morning. Connected. Okay. This is the moment when the local provisioner started and the Restic role will come into place. Will start executing. First of all, we are ensuring that the Restic software is installed on a CentOS 7 image in the case of the server well-being. And this is what actually I was explaining about Ansible. These are the names, what I highlighted are the names of the tasks Ansible executes against the managed nodes. So we know at every moment what is happening on the server itself. This is what I meant by the fact that the manner we write Ansible code is self-explanatory and it is a documentation of the infrastructure itself. Okay, this started going very quickly. And it's really good. SSH keys are deployed, the necessary directories are created. Okay, the backup script is in place and we got our IPs. What I'm going to do next, I'm going to connect to the server. Okay, what I need is to add the floating IP. Okay, and now, voila, this is our website. The Ansible role also deployed a script which has been included in a cron job in order for regular backups to be performed. However, taking into account the fact that I have just executed the Restic code against the managed node, no regular backups are taken up to this point. This is why I'm gonna forcefully execute this in order to be able to have at least one backup. So this script has told me that there have been 2 files backed up, and the snapshot ID will anyways have only one snapshot. And next, oh god, I have accidentally deleted my server. What do you think, Radu? Am I able to recover the nice website I was actually showing? I quite enjoyed the image.
I don't know. It depends if the backups work or not. I'll say
Okay.
50-50. I'm joking.
I should get
99,
do I
1%.
do I get a coffee when I get back the data?
Sure, we can arrange that. We can arrange-
Oh, very nice of you. Let's see what happens next. Let's try to restore everything. And this is the moment. Oh, I needed to show you something else. Vault, what happened here actually? In the Restic engine, there appeared an entry with the name of the server we have just provisioned, and that is samedin.raw. And within this, we see a key value pair. This is the name of the backup, which backups the content served by the web server, and of course the password, which is not, which, well, I could show you, but it's of no use because I'm gonna destroy the server afterwards. The restore playbook of Ansible will retrieve this data in order to be able to read the snapshot performed by the backup program, in our case Restic, and restore it to a custom location I have already specified. In my case, I'm gonna perform a restore of the data on localhost under the TMP directory. And let's see if this happens. Well, I need to be able to have the software, the Restic software on my localhost as well. I have provided only some variables, and Ansible simply does its magic behind the scenes. And it's done. It took like 3 seconds or maybe less.
Not bad.
And let's see if I deserve that coffee. Under TMP, I should have, well, I have the HTML and the image you have just seen. Despite the fact that I've accidentally deleted my server. I'm really sorry, guys. Mistakes happen. And as humans, we are prone to error. The variables I have fed to this role are the following. I have specified that the restoration should be performed on localhost, the server whose the backup belongs to, the actual backup, where the backup is to be found, and by that I mean the backup server, where I want the data to be restored to, which snapshot, and furthermore, we are able to restore either the entire snapshot or only a certain file or a certain subset of files. Where we started and where we are now. We started with an issue. What happens in case we lose data? How do we recover them? And for that, we have identified two opportunities, I would say. First of all, how to perform backups in an automated manner, and moreover, how to restore the data very quickly in order to be able to restore services for exchange. This is the moment when everything did come together. Well, this was the presentation. The code and everything, including the presentation I've shown, will be soon available on GitHub. I'm gonna share the link with you guys.
Yeah, we have a group on Facebook. I don't know if you're part of it, but if you're not, I'll ask Doreen to invite you and share it there with everyone. I
Uh,
have a question. All
Please,
the tools that you have used, are all of them free/open source or
yes,
free and
everything is
open
open.
source? Perfect.
Everything is open source.
Perfect, including your presentation.
Most of it.
Awesome. Okay, so
Everything.
if anyone has any questions, this is the moment to ask them, so I can ask them further. Um, and yeah, thank you for the presentation. It does seem uh, like a piece of cake to recover a deleted by mistake server. It's funny and sad in the same time because that sometimes happen. Uh, Deleting servers or deleting parts of the code or uh, yeah, errors happens all the time. So having a backup that's so
Well,
fast to put it back is quite nice.
actually, to be bluntly honest with you, uh, as I've been using Hetzner Cloud, it has a feature quite nice in my opinion, which is called protect deletion. This means that you are not able to delete a server unless unflagging this feature. And I'm extensively using this. Let me show it to you. For example, for the backup server, which is the only one alive, there is this lock icon. This means the protection is active. So if by any chance I issue a Terraform destroy code command, I could in theory destroy the server, which I don't want to. Well, this feature will prevent me from actually destroying the server.
That's actually nice. Never used the cloud part of Hetzner, only the bare metal part, the robot Hetzner robot part. But this seems indeed nice.
Yeah, it is. It is, especially when using an infrastructure as a code tool, such as Terraform, when a simply Terraform destroy could tear down a quite number of a servers. So
So your solution is best. Usually, most cloud providers also provide a way to snapshot your server and recover it. At least I remember Hetzner Cloud does that, and Google Cloud for surely has that. Um, why write code when you can triple click a few? I want backup to this server exactly, and that's it.
well, I hope
I mean,
hopefully,
I'm trying to get from you a few use cases why this approach is more desirable.
despite the fact that I have used Hetzner Cloud for this demonstration, this approach also applies for servers which are on premise. This is the advantages. We are not, let's say, locked within a cloud provider, regardless which one this is. For the ease of this demonstration, this was my choice, but I have could easily used any server on premise and been able to restore data as easily as I've shown you.
Awesome. Yeah, this
That
is a perfect solution for not being locked
that's
into a
That's
provider.
actually the main advantage of this solution. We are able to either restore data from a server in cloud, no matter which cloud provider we are talking about, either a server on premises. And moreover, as said, no tool is, let's say, vendor locked in. Everything is open source. And, well, let's say I'm quite an advocate of using the latest versions of everything.
Awesome. Yeah, and I guess this is also a nice way to not only use it as a backup tool, but I guess you could also use it in case you want to move to a different provider and reestablish servers from backups to another area.
Well,
For
actually,
example, if you
you
have everything on premise or everything on Hetzner and you want to move to, let's say, another servers on premise or Google Cloud, for example, this would actually also be useful for that. Or am
yeah.
I talking?
No, you are pointing it quite nice, and also I would like to showcase another interesting use case. What do you know about short-lived environments?
They're way cheaper.
Well, actually, the purpose of short-lived environments is for testing purposes.
Oh, I thought
And
you were
this,
talking about, sorry, I got confused with, for example, Google Cloud has like GPUs that they might disappear, like
uh,
servers and GPUs that they might disappear, but they provide
uh,
them at a lower cost.
no, what I'm meaning is the following. Let's say you are planning a delivery in production for the next week, and you need a full-blown environment in order to test the latest features. A full-blown environment which is actually a replica of the production. Assume this. I could tell you that within at most a few hours you could have this environment. Provisioning the servers using Terraform, restoring the data from production in a new environment using the restore operation I have just shown you from backup. And the developer teams are able to have a perfect replica of the production in order to test before actually going into production. After the migration, this environment could be teared down.
Yeah, that sounds very nice. Very nice. We have a question.
Okay.
Someone asked, just curious, what was the biggest backup you had to restore and how long did it take?
If I'm not mistaken, Terra or Giga. And to be honest, I'm not quite sure about the time because everything happens behind a cron job and I didn't follow times.
Okay,
But
so
but I could say that the quickest restore took a few minutes.
a few minutes. So
And
everything
and
happened.
I had thousands of files.
So everything happened while you were not watching, maybe sleeping.
Most probably. I enjoy backups and servers working for me while I'm sleeping.
That's great. So it can also be used in case a server has a fault to tear down that server and remake it from the last backup in case errors start popping. And
Indeed.
there's no one there to actually see and handle, so it's faster to actually
Also,
restore
for
that.
debugging purposes, depending on the, let's say, backup policy one defines, depending on the needs, because I cannot propose a certain policy which is universally applicable to each of us. A developer or a team could use certain data to go back to for debugging purposes. What changed within a time frame? Or maybe I need only a certain file which I deployed, let's say, 2 months ago. As long as I have that backup, I'm able to restore the single file.
That's nice.
So this is
Awesome.
it's only about the retention policy, let's say, in that case.
Yeah, yeah. Awesome. Thank you very much for your presentation. It was super interesting, and I think people will be looking forward for you sharing the presentation and the links to everything so they can give it a try themselves as well, because it's always better when you try it for yourself.
Thank you as well for the invitation, and thank you, the audience, for the feedback, especially during the presentation. I would also take one other moment, please. I would like to thank my current team leader, a good friend, and an exceptional professional for guiding me into realizing this project. I think he's watching me now, and it is my sincere thank you for having such a great man beside me.
Awesome. Thank you as well for training Elif to do such an amazing job here as well. And yeah, thank you for the presentation again.
Thank you, guys.
And now we'll continue with our second speaker, Daryl Cullen, if you're around here,
Yes, hello.
and you are.
Nice to be here.
Nice to have you here. As I previously mentioned, and I'll intro Daryl again, he's currently DevOps Cloud Manager at Ericsson and previously Director of R&D at Volvo with a vast experience in a lot of domains from air traffic, nuclear, space industry, and automotive. And he will present to us today how at Ericsson they're accelerating innovation in automotive through cloud connectivity. Before you go fully fledged into the presentation, with definitely be interested to learn more about your experience and your background and the whole trajectory through the multitude of domains and what inspires you and what inspired you to be better.
Oh, that's a good question. I mean, I've always been interested in software. As a child, I got, the little ZX Spectrum. I don't know if you know that computer. And I was sold on software since then. It's the magic that breathes life into the hardware. And, it was like a real creative process, creating software. So it's where, creativity and technology meet. And, it's been a real passion of mine since I was a child, basically. And I've got to work on some pretty cool things.
I
And
imagine.
I've had the fortune. Every project, every company I've worked with has gone to production. I haven't worked on any vaporware yet, so I hope not to start doing that. But it's I know it's a very fast moving industry, the software industry, and I've probably gone through every single fad, every single way of working, every tool, and I've really the CI/CD and the DevOps movement really resonates with me because I see that it actually makes a concrete difference and it makes things better for everybody. I'll talk a little bit about that as well. Also, open source. I was very early on the Linux bandwagon. Even I was reading the emails from Linux when he was saying I've got this toy operating system going. So yeah, I've got a long experience, and but right now I'm working with a world leader, I would say, within connectivity, and that's Ericsson. And I'm really excited to talk to you a little bit about what we're doing in the automotive space. I mean, most people think of mobile phones and mobile networks when talking about Ericsson, but there's a lot more to Ericsson people know. So I'm quite happy to talk to you about that today.
Yeah, and we're looking forward to that presentation. And it's amazing to have you here, especially since you've been through like from the inception of the internet and software to now. So
Definitely, I have lots of
awesome.
stories there. I won't go into them, but I think the university I went to was the sixth university in Europe on the internet before the internet was available at homes. So I did mudding, if you know mudding. It's like a text-based adventure multiplayer game. I met lots of cool people in Europe. So that was my first internet experience, and things have changed a lot since then. But it's exciting. It's an exciting area to be in. So thank
Hopefully
you.
you'll join us again and share even more in the future with us. But thank you for being here, and we're looking forward to your presentation.
Definitely. Okay. Yeah. So as you heard, my name's Daryl Cullen. I'm currently a DevOps manager at Ericsson, based in Gothenburg in Sweden. I'm an Englishman, but I live in Sweden. And I thought today I'd talk to you a little bit about vehicle connectivity and how we can enable easy connectivity for vehicles then. So let's see if, yes. So I've already talked a little bit about myself, but before I started at Ericsson, I've been at Ericsson now for 3 months. I was working for a company called Aptiv, one of the world's largest automotive tier one companies, working on a project to implement Android natively in the cars. So I don't know if you're familiar with the Polestar and the Android interface in that. I basically was responsible for the entire CI/CD setup for that. So it's a pretty heavy software stack, Android, as you know, made up of thousands of open source projects. It's a massive build job, and to combine that with the embedded hardware and the CI/CD chain was a big challenge, but it actually went really well. And as you can see, it's out in the cars today. So if you look in the Polestar and some of the XC40 electric, you'll see the Android interface. So what Android enables is for the automotive industry to actually open up their vehicles in a limited way for app developers. So as a third party, you can download today the simulator for the screen you see on there and develop apps basically for Android cars. And that's growing crazy right now. I think just about every automotive company, apart from maybe Daimler, are implementing it. So having done that, I was very interested in the other side, which is the connectivity side, then the back end, let's say. And that's one of the reasons I moved over to Ericsson. See if there's anything else I want to say there. No. So currently I'm working in the IoT Accelerator division at Ericsson. We have a whole division working just with Internet of Things, of which Automotive then is a subdivision. So this is enabling an infrastructure for automotive apps on the back end. So today I'll give you a little of an overview of Ericsson itself, a little bit of an overview of the car and how the car's changed. Also talk a little bit about our cloud infrastructure. Unfortunately, I don't have a cool demo like Elif on the command line. I would have liked to do that, but maybe not today. So I'll mention some of the success factors we've had, which is, I think, 3 areas that might be interesting for you: GitOps, cybersecurity, and open source, and just some conclusions. So,
awesome.
Yeah, if we look at Ericsson, then Ericsson it's a pretty big company. It's 100,800 employees, based in 180 countries, and with a turnover of 232 billion SEK, which is quite a large turnover. It's, if you divide by 10, you get it in euros roughly. So we have, of the 100,000 employees, 26,000 are research and development staff located across the world. We have pretty much every language, every culture. We serve customers everywhere. We're the world leader in 5G, as you know. In some countries, we've been there for over 100 years. China, Brazil, India, we've been in place over 100 years. And things are going well. Turnover went up 2% last year. So it's looking good. But looking at the vision then of Ericsson, we imagine a world where limitless connectivity improves lives, redefines business, and pioneers a sustainable future. So our vision is a place where technologies and innovations will open new possibilities for our customers, whilst also helping to resolve some of the greatest challenges, the sustainability challenges we have today. So we like to imagine a world where limitless connectivity means limitless possibility. And today we're going to explore how Ericsson has helped shape that connected world. And we hope to continue to play a pivotal part in that even going forward. So as you know, we're like the world leader in 5G currently, and that enables a lot of new business models. So you need to try to imagine, how do we make the unimaginable possible? You can really think like, very future with this. I think when we come to 5G, you're going to see everything connecting to everything, and that opens up a whole new world of possibilities, right? So, I mean, who would imagine how big the app economy would be like before apps came out? No one really saw that coming, did they? But our networks basically have enabled the whole app economy. We created that technology first, and we will continue to innovate in that space. Yeah. So when it comes to automotive, there's a major transition going on. The way people are moving is changing. The way the things are moving are changing. So not only is there a revolution going on the network side, there's a revolution going on the automotive side. And there's also a revolution going on in the software industry around open source and cloud, right? So how do all these things come together? Well, we see the 4 main areas. It's connectivity. I mean, today we see that only 10% of cars are connected, and that's rapidly increasing. But it's definitely in the center of the transportation ecosystem. Autonomous driving is a major factor, which is also enabled by our networks. New business models, so things like carpooling is, and the way that the OEMs are selling their cars as a service, more than you go out and buy a car and that's it, you own it for life. And of course, electrification, and that's a major change, because unfortunately, what it's doing for the OEMs is that they're becoming more and more similar. There's only so much you can do with electric motors and batteries to differentiate. So everything moves over to software, and how can you differentiate the software ecosystems in the car? That's who the next winner will be. And as you know, Tesla are doing a good job in that space, so everyone's playing catch up at the moment. So if you look at what is a car these days, well, actually it's a traveling data center. It's a very powerful computer these days, and it doesn't exist only physically but also virtually. We have a virtual copy of the car in the cloud, which can track all of its capabilities. So we worked out by 2025 there'll be 10 exabytes of data a month going between cars and the cloud. The diagram you see on the right are basically the areas we work in. So we have solutions for telematics. Telematics is the communication with the car, the communication protocols. We have service innovation, which I'll talk quite a bit about today. It's the app infrastructure and how we manage the services and apps. Fleet management, we offer services to fleets. Assisted drive is to do with autonomous driving. Software over the air is about how you update the vehicle. Universal connectivity is an easy way for our customers to begin with connectivity. And of course, offering cybersecurity is an umbrella over all of that. So those are our sort of main areas of interest. Looking into the car, just to give you a little bit of history of what's happened at the car, because that's kind of interesting, is that we've gone through 5 generations or 4 generations, and we're going into the 5th. The first generation was the point-to-point network, so nothing was really connected onto a bus. The second generation you see there is, okay, we started to get more ECUs, and ECU is basically a computer driving a function. It could be a window switch, it could be the gearbox. And that's where you first started to see early buses, like CAN buses. Then the third generation, where you see these cross-functional connections. So ECUs could talk more across functions. And then most cars today have what's known as a domain centralized architecture, where you separate each ECU into different domains. So you might have a domain for, let's say, body control. And then you have a central gateway which communicates across the domains. Unfortunately, the cars that we have today, they are extremely complex. You might see up to 220 computers in a car today. And that's a lot to manage. And it also makes change very difficult. To implement new functions is very difficult today on the classic architecture. So what we're moving to is the computer on a wheels model, which is the zonal architecture, where you have a zone control at each corner of the car, so usually 4 to 6. And it's a quite powerful computer in each zone, and they will be connected to the different mechatronic components. And the actual business logic sits up in a central computer, and the network between these zones and the central computer is extremely fast. So it could be a PCIe bus that's actually drawn out to the zones. It can be a 10 or 100 gig T network, industrial network. So what that means is that the cars are producing a lot more data. The central compute node is typically a blade computer. It can be water cooled. It's so powerful. It'll have a blade for autonomous drive with deep learning functions for being able to deploy models. And then you'll have maybe a blade for infotainment for the Android that I was talking about earlier. So that's where we're moving. It's actually a much more simple architecture, believe it or not. There's less cabling, there's less computers, there's less to manage. But what you have then is a lot more software. So you need to be able to update that software regularly. And that's where we come in with our high bandwidth and reliable connections. So what we provide the Connected Vehicle Cloud, which is an application enablement platform, which gives then our customers a way to innovate on top of our platform. They don't need to think about the details. They can basically write apps, and we abstract away the complexity. We also offer connectivity management. So, a typical large OEM doesn't want to have to talk around 150 different telecom companies, CSPs as we call them. They want to talk to one partner, and that would be us in that case. And we offer things like, 5G functions with edge computing, network slicing. Network slicing is where you offer a specific part of the bandwidth, which gives you your own dedicated network. And then we're global then, so this scales globally. I'll come a little bit to that later as well. So today we're managing 5 million vehicles in 130 countries. And I would say we were the first, or one of the first in this area. It's become, unfortunately, a very strategic area for the OEMs. So a lot of the OEMs want to do this themselves these days, but we still have quite a few customers that are on our platform, and we're growing. We have a lot of experience in scaling up and using public cloud, because this is public cloud then. So that's also was one of the first to actually use public cloud. I'm noticing the time here, so I'll speed up a bit. So how drivers are connecting with their vehicles is fundamentally changed. These software infrastructures give a whole new meaning to OEMs and how they derive value from their products, and this gives a rapid development possibilities. You can deploy new software to the cars, both the firmware of the cars and the applications between the back end and the cars. So some typical areas of innovation are things like the firmware over the air, that you can update the entire vehicle, not just one or two ECUs, but the entire vehicle. So you can implement completely new functionality. Obviously, if the hardware is there in the car. I think you see that pattern in Tesla a lot. They fully equip their cars and then they can come with new features afterwards. Autonomous drive, the car is a sensor. It's bringing in a lot of data about the roads, and we can then bring that data back for the retraining of the models. You can do things like carpooling and sharing, which might be an app on the Android. You basically can get a digital key to get into the car, and it can be automated the whole way you share vehicles, share your own vehicle as well. Fleet management, there's a lot of big fleets out there that are not being utilized properly. Councils that have thousands of vehicles parked up and they're not earning any money for their owners. Safety and security, there's so many use cases where maybe a car might detect that it's slipping on ice and it can then communicate that information to other cars in the area. There's a good safety use case. There's smart cities where basically all infrastructure talks to the cars and the cars talk to the infrastructure, so that can make flow through cities much more effective. And then, like I say, the OEMs can develop new functionality on top of that with in-car delivery, for example, where you log in, you buy your Amazon package, and you want it to be delivered directly to your car wherever the car is. So the delivery firm will get a digital key. They'll be able to open the boot once, drop in the package, shut the boot, and it's been delivered. So it makes people's lives easier, right? It's a bit of a hassle going to pick up these packages, so they should come to you. Yeah. But there's a lot of stakeholders that develop apps on our infrastructure. There's the dealers, there's insurance companies, there's aftermarket providers. The OEMs themselves want to monitor the vehicles, maybe do predictive maintenance where they can see if something's going out of line, so they want to maybe bring the car in and fix it. And even tech companies are trying desperately to get into this space. So looking at maybe what's yes.
Sorry, I have a question because you mentioned vehicle to vehicle and smart cities, and I was thinking, like, is there a standard, or is someone, maybe Ericsson, that's trying to come up with an open standard that everyone implements so that vehicles can communicate with each other in the same language, or smart cities can implement and talk with all the vehicles no matter who produces them?
There are lots of initiatives going on, and that's the problem. There are lots of initiatives. So with standards, there's so many to choose from. Yeah. There's an old vehicle-to-vehicle standard in the US, but basically that got shot down due to public liability, that they thought, what happens if there's an accident? Who's to blame? So yes, there are. Even the W3C has a car API. There's a lot of people in the space. Ericsson is involved there as well. Yes.
So it's trying to at least come in the same direction and have one standard and not 20.
Yes.
And, yeah, that's great.
Yeah.
That's great.
Yeah. I'll talk about standards later on with cybersecurity as well, because there's a new standard coming out around that for automotive. It's quite interesting. But our solution then is cloud agnostic. I say cloud agnostic, I would say AWS and Azure are the preferred solutions. We do a lot of infrastructure as code, and listening to Elif, we're using a lot of the same tools you're using there, Terraform and Vault, for example. It was music to my ears to hear Elif talking about automation, because I very, very much believe in automation. So we do a lot of continuous testing, a lot of continuous deployment. We do trunk-based development, shift-left security. We're delivering as a service to our customers. We deal with containers as much as possible, and we use a GitOps practice. We're using SAFe, which is a scaled agile. We have 3 release trains and 1 over solution train with a total of 30 Scrum teams. So this is quite a big operation. Looking at our tech stack then, we have GitLab and Gerrit for our source code management. We use Kubernetes for container orchestration, and we have our own operators developed in Golang, and we also have actually developed our own Kubernetes written in Golang. So that's kind of interesting. We have our CD implementation is based on GitOps. Like I said, we have our own Artifactory. For the infrastructure as code, we're using Flux and GitLab a lot, and Terraform. Like I said, cloud, we're mainly focusing on Azure and AWS to get the biggest coverage. We're using Jira and Confluence for our workflow. You mentioned Ansible as well, Elif. We're using Ansible, but for software configuration. Ansible typically doesn't work so great on infrastructure, so there we use Terraform. We're using customized and Helm charts there as well.
What do you mean Ansible doesn't work so well for infrastructure?
Yeah, we found some limitations with Ansible and infrastructure. We found that Terraform was better and more suited for cloud infrastructure, at least.
Well, let's say Ansible is responsible for configuration management mainly. It could also be responsible for infrastructure as a code, but it's not main purpose.
Yeah.
Terraform is mainly responsible for infrastructure as a code. So we are discussing about two different, let's say, responsibilities.
Yeah, and we use both, but we try to use them for what they're good at. So we do more configuration with Ansible and more infrastructure with Terraform. So like I say, and also one of our main findings is that we try to be as cloud native as possible. When you're developing these large systems, it's much better to use the services provided by AWS and Azure than spinning your own. So if you're going to use Kubernetes, use EKS, right? I don't know if you're familiar with GitOps, but yeah, GitOps is we're using Git then for defining for controlling the infrastructure. So in the Terraform scripts, if an update's made, we have Flux that's listening to certain Gits, and if there's a change made, we'll automatically apply the infrastructure updates to our Kubernetes cluster. So a DevOps engineer will push his Docker container to the Artifactory, and Flux will automatically pick that up and deploy it to the cloud and Kubernetes. So that's kind of cool and works pretty good for us. I talked a little bit about cybersecurity. Basically it's our highest priority, security. There's some nightmares that you can go onto YouTube and find some pretty scary videos with vehicles being taken over remotely. And that's not okay, obviously. So there's actually a new standard that's come out. I've actually worked on this standard as well, the 21434, Road Vehicle Cybersecurity Engineering. If you're looking to get a job, if you know this standard, you will have a job for life, basically. It's based heavily around ISO 26262, which is like a functional safety standard within automotive. So you basically define your system and you identify the most risky parts of your system with the CAL. And you do what's called a crown jewel analysis to make sure that this particular part of the system no one can ever get in. And you do this TARA, which is a threat and risk analysis. So it's about managing risk throughout the life cycle of the vehicle and the connectivity parts. It's not just the vehicle, it's the entire system, if you like, through the whole production, operation, maintenance, and decommissioning. So if you get a chance, I would say look that up because that's coming. And actually, if you don't fulfill this standard in the future, you won't be able to sell your vehicle because you won't get a UN type code. So it's mandatory. When it comes to open source, we're heavy users of open source. Everything we do is open source. Every component we use is open source. So managing those components is key. We have built it into our CI/CD chain. We do scanning on the source, make sure there's no vulnerabilities, and that we're following all licenses, which is obviously very important.
And the nightmare.
Yeah, exactly. We're using Black Duck, Nessus. We have our own internal developed systems where we monitor different open source and recommend when a developer wants to find open source, we recommend what you should use. So developers are not just pulling them in. When you have a big team, you don't want just people pulling in open source. You need to know your licenses and how they're used. Like GPL Ethereum can be a problem, especially in a cloud scenario. So we manage the open source centrally, and we proactively monitor for vulnerabilities, even for already deployed code, especially for already deployed code. Like Elif said, you need to run the latest, basically, which can be problematic sometimes, but it's better than the alternative. and then an upstream first policy. So if we do make any modifications, we upstream so that those changes are maintained upstream, basically. Running out of time. So basically, some of the examples of the challenges we have are managing all of these CSPs globally is a challenge. What's known as zero-touch provision. You want to be the provision of the eSIM in the car has to go as easily and as quickly as possible. So as soon as it comes off the production line, you want the IMEI number to be provisioned on the network. And scaling the infrastructure to the right size is important. You know, we're looking at lots of cars here. It's a lot of infrastructure, and the costs can be quite high if you get the scaling wrong. So we're looking into spot markets, as you were talking about earlier, using the spot markets to keep the cloud costs down. And, you know, as I was talking earlier, the vehicle software size is increasing incredibly. You know, we're looking at quite a lot of gigabyte images. So that's a challenge for the networks and the cost. So you typically use these low cost times over the middle of the night where you can flash down cheaply. And yeah, things like when a car drives over a border and has to hand over from one telco to a telco in another country completely seamlessly without any disturbance to the network. And that's a project we've worked on recently within the 5G Crow, showing that when we drive over borders, we can have a seamless connectivity, which is really important for map data, especially HD map data. It needs to be updated regularly over the network. So that's you can check that out if it's interesting. So the conclusions are that the vehicles are becoming more and more software defined. They're always connected, and the bandwidth they need is becoming higher and higher, and the reliability they need is becoming higher and higher. But that this connectivity then does open these new business models for the automotive industry, new services, new data sources. As we know, data is where the money is. Data is the new oil. And then we know that the OEMs themselves are becoming highly software focused. They're becoming more and more software houses. Look at the Volkswagens. They have CARIAD. It's 4,000 software engineers. Pretty much all the OEMs are building major software organizations because this is where the future battlefield is for automotive. And they need to innovate as fast as possible. And that's where we help out. And the customers are becoming more and more picky, expect the cars to just work. If you sit into a car, you want your profile, you want all of your apps already there, all of your radio stations. You know, it's about you, not the car, right? So that has to follow you around. And cybersecurity, data protection, key importance, as this is, you know, a lot of information. There are sensors inside the car that will be looking at you, taking pictures of you, measuring your breathing with radar. There's all sorts of personal information, so that has to be protected according to your wishes, according to the GDPR. And I would say that we've had a good journey here with using DevOps, open source, public cloud. That putting those three things together has been really powerful for us and has given us probably one of the best solutions out there. So a little bit, this is the hook now. We do have an office in Bucharest, and we are looking for people. So if you're a Golang programmer, Java programmer, if you're into Linux and cloud and Terraform, get in touch with Soren, who's our local manager there for Connected Vehicle. We like I said, we're 30 teams, about 200 professionals currently, 3 sites in Sweden, China, and Romania. And yeah, we're a full DevOps outfit working to be the best DevOps we can be. I think that's my time up, isn't it?
Yeah, we still had a few, so I have a few questions.
Questions.
Like you talked about bandwidth. Do you have some numbers? How much data does a vehicle outputs to the cloud, or
yeah, I mean,
how
that's
much
it.
data?
I can differ a lot. I mean, I can tell you like an Android update can be about 20 gigabytes. So if you're doing an Android update for that day, it'll be 20 gigabytes. Just the normal telematics, I think you're looking in the megabytes, the 50 to 100 megabytes perhaps. It can vary a lot depending on the implementation. But the Android and the central compute firmwares that you're soon going to be up into maybe 200-300 gig.
And from the side of the actual driving, like telemetrics and stuff like that, do they stay on the car or are taken to the cloud as well? And if they are taken to the cloud, they're in real time?
Yes. Telematics to the cloud in real time, definitely. So we use like MQTT as a messaging framework. There's different ways of interacting with the car telematically, but it's of course highly encrypted. There's a full encryption, and the keys are closely guarded by the OEMs. So yeah, no, that's a interesting area.
We have a question from one of our members. Your personal opinion on cars using Android. What are the alternatives? Are there any alternatives?
Yes.
As you said, data is king, and Android is well known for farming data.
True. I'm a little bit ambivalent, like you say. The alternative these days, there is only one more alternative, and that's to roll your own Linux. There's Geneva, which is an open source based. Well, there's a couple of open source Linux efforts actually, but honestly, they're not commercial ready. So you basically have to roll your own, which is what like Daimler Mercedes has done. They've rolled their own. What you see in that is a Qt based system. But honestly, it's like, why would you use Android on your mobile phone? It's exactly the same argument. But there are a lot of benefits, and honestly, it gives a much better customer experience. The voice recognition, the data, the apps. It's such a rich ecosystem. So it's a little bit of personal preference and what you want to do with your data, and what if you're happy, with Google's presence in your life.
It's also open source, and everyone's contributing to it.
Well, the Android open source project is open source.
The Android Auto isn't open
But
source.
the App Store and the services that Google provide on top of that are not.
That's correct. That's correct. Are there any alternatives? I've seen Samsung trying to have an app store, Huawei with their own app store since they
Now,
got banned.
who's interested in developing an app for like 1 million cars when you can develop an app and develop it for 100 billion devices? The market's just not there. So that a lot of OEMs have already failed that, trying to put their own app stores out. There's no one's interested. There's no volume. There's no income. So it's just not going to happen.
I see. Okay, and a question about the future. How soon do you see like fully driverless cars, and how soon do you see putting your car to work for you and becoming a taxi for you? And how soon do you see smart cities actually becoming smarter and making that traffic light green because there's only you on the road?
That is an excellent question. I think a lot of people are a bit negative and think this is never going to happen. I'm actually the opposite. I think 3 to 5 years you will have a fully autonomous vehicle, and the big boys, the Teslas, the Volkswagens, the Volvo cars of the world, they will have those solutions. I mean, it's about when you get for autonomous drive. We're talking just autonomous drive. It's when the vehicle gets to the level of being at least as good as the worst human driver, and we know some pretty bad human drivers out there, right? The problem is when you're in a hybrid solution, when you have a mix of autonomous cars with humans, they don't go together very well. If everything was autonomous, it would probably work a lot better. But we have to go through this phase of having a mix of human drivers and autonomous drivers. Aptiv, where I used to work before, is the world leader in autonomous drive, actually. And I could just see the amount of money and research going into that area, and the speed of progress. Absolutely incredible. Absolutely incredible. Look at some of the videos on YouTube of Tesla's latest beta. It's amazing. They're very close to solving this problem. What's the other question? Smart cities. Well, that's an investment thing, and it's a lot of infrastructure. It'll come. That'll be a bit longer. I think we're looking at like 10 years, maybe 10 to 20 years. There's a lot of benefits around for the government for those kinds of initiatives.
Awesome. And we have another questions regarding the Android and the operating system. The market isn't there yet, but I'm sure those who are wary with whom they share data with would go for alternative OSs in their car.
Yeah, unfortunately, I think like 99% people are not really as conscious as we are about our data or how it's being used. So they're just happy to have the fancy apps. I mean, honestly, I'm a supporter of it, really. It's Google, they use the data, but it's anonymized, and if you read what you're signing up to, I think you understand how it's being used. So for me, the benefits outweigh the negatives.
Yeah, I'm with you on that one. I agree. There are a lot of benefits, and you can also see that with operating system on the actual computers, like Windows and Mac OS are the top ones, and Linux is the top one only on servers, but on
I mean,
personal usage.
if you're on Facebook, I don't think you've got any room to complain, basically, because you're there giving away your personal data on TikTok and Facebook, and and to complain about your Android in the car, it's like,
Yeah, and people are watching us on social platforms, so
exactly. That's
true.
a lot of. I've given a lot of personal data today, haven't I, about my history and where I've
A
worked
lot.
and where I'm working now, and my email address. So.
And voice data and
Yeah.
facial expression and everything. We can now use that to do some deep fakes and yeah, it's
Yeah, but
scary.
like I say, there's a huge amount of change going on in this area, as you probably see in the media every day. It's amazing amount, and mobility is super important from a sustainability aspect. And there's a lot of things we can do to improve lives. What I really enjoy is improving people's lives, making people's lives easier. People who maybe are blind and can't drive, that the car will drive home. For me, that's a major positive, right? So it's there's a lot of things that we can get from this.
I'm definitely looking forward to a world where all cars are autonomous and they're no longer staying parked on the side, but they're always driving and making the
Yeah,
city less crowded and
exactly.
way easier and more room for you to actually walk on your feet and maybe with a bicycle or something and clean up.
Agree.
Awesome. Thank you very
Thank you.
much, Daryl, for
Thank
the
you.
presentation. It was amazing and eye-opening. Imagine possible. Imagine anything
Yes.
is possible, definitely. And
All right.
thank you all for watching. And if you have any more questions, you can put them on the Talks by Softbinator group. We'll invite Daryl there as well. And we'll also prepare this video for later viewership on YouTube. And thank you all for being here and see you all again in 2 weeks. Thank you again, Daryl. Thank you again, Elif, for the amazing presentations. And talk to you all soon.
Thank you.
Awesome. I now have stopped the streams.